All right. So we did this one. This was one example, and you could check this using Desmos. Okay, that's really good about this. You can check it using Desmos. Let me get this thing going. Okay, can they hear me? Good. Okay. You know, if you were to graph this in Desmos, right? You know, we have done that before. Okay. You would actually see that the two equations intersect at the point -3, -4. In fact, I'm wondering if I should graph it now. I guess, nah, it's all right, I guess. So you can use Desmos graphing. I mean, I know that's technically another way of solving it, but, you know, you can use it as a way to check, I guess. All right, good. All right, let's do another one then. So here, right, what we have then is this system of equations, and we're going to solve this using elimination. So we're doing another example. And really, you can see that this is just like, right? This is just like what we did just a few seconds ago, actually. You know, in other words, we have fractions in here, but we can fix that by just clearing fractions, right? You want to basically clear fractions. I mean, normally you would just have to multiply both sides of the equation by a common denominator. You know, again, it's just like solving linear equations that we did in the beginning of the course. I guess not the very beginning, but in chapter 1. But here it's easy because 3 is the only denominator, really. So we just multiply by 3. So we have 3 times, so we multiply both sides by 3, okay? And from here, we have 3 times x minus 1 over 3 times y equals 3 times 11/3, as you can see. What happens over here? We distribute the 3. That's what we're doing. Over here, we have 3 times this. And so what happens then? We get 3x. Here, let me get that pen out. These 3's cancel. So do these. And so we get 3x minus y is 11. Now that's only changing the first equation. So now the system becomes this, as you can see. That's what this system is. But it's probably easy. I mean, again, you want to eliminate a variable. So I say solve by elimination. But hopefully it's easy to see what you can do. I mean, if you were to just add the equations, right, the y variable vanishes. Okay, the y variable goes away. So in other words, so if you just add, right, you have minus y and y. Here you get 0. Well, I guess 0y, which is still 0. 4x plus 0 equals 12. So 4x equals 12. That's what we end up with. Okay? Now, what we can do next is divide both sides by 4. Doing so, we figure out x. On the left side here, we get x, the 4's cancel. Again, here it is. These 4's go bye-bye. You get x equals 12 over 4, which is 3. That's what we get here. We get x equals 3. And now that we know what x is, we can easily get y. You just substitute x into either one of these two equations. Personally, I think I did the second. Yeah, I did the second equation because, it looks a little bit easier than the other one. 3x minus y is 11. But really, either equation, it really doesn't matter. So from here, we have x plus y is 1. Again, you could substitute into either equation. So if x is 3, right, that's what we did. We get 3 plus y equals 1. Then we subtract 3 from both sides. And we get y equals minus 2. And so the only solution then is 3, negative 2. And of course, we can always check our answer by graphing, right? You know, you could always graph this such as in Desmos, and you'll see there's only one point of intersection, and that point is actually 3, 2. All right, that's fun. Are there any questions on this? Okay. All right. So I wanted to do also, again, we're still reviewing, right? You know, till the exam, I guess, so to say, till the last day of classes. For us, at least. You know, really, there's only one class next week, right? Because Monday's a wellness day, so. And classes end on Thursday. So I figured it'd be good to do these kinds of, a little bit with these kinds of questions. We have the absolute value equation. So we have the absolute value of negative 3x minus 4 equals 8. And remember, how do you solve this? You're going to get two equations from it, right? Namely, we have minus 3x minus 4 is 8, and minus 3x minus 4 is negative 8, right? Because you're looking for all x so that this equation holds. And this is how we do it. We want to we solve these two wonderful equations. Okay, that's what we solve. Okay, so let's solve them. So for the first equation here, we have minus 3x minus 4 is 8. Right? We're going to add 4 to both sides. We're going to add 4 to both sides. So we get minus 3x equals 12, right? Okay, so minus 3x is 12. So what do we do next? We divide by minus 3, both sides. On the left, we get, wait, let me get that pen thing out. We get minus 3's cancel. We get x equals 12 over negative 3, which of course is negative 4. Okay. Now, we're not done, of course. That's only one solution. What about the second one? Well, that's what we do here. It's actually very similar. The steps are almost identical, actually, which is nice. Okay. All right. Okay, so minus 3x minus 4 is negative 8. That's what we want to solve now. Okay, we have two equations to solve. We solved this one already. Let's solve this one. So we have minus 3x minus 4 is minus 8. So we want to get x all alone, right? So just like before, we can add 4 to both sides. That gets the, because we want to get x all alone on one side. So that gives us the minus 3x all alone on one side. So we have that equals negative 4. So minus 3x equals minus 4 we have. Okay. And what do we do next? Again, we want x to be all alone, right? So we divide both sides by minus 3. On the left, just like before, these cancel. Okay? We get x equals 4/3. So 4/3 is another solution. Okay? Remember, here we're not going to get like an interval. You're not going to get, you know, anything like that. You're only going to get two solutions here. okay? I mean, if instead of 8 we had 0, then there'd be one solution. I think we've seen that before. But you're not going to get an interval here, is what I'm saying. Are there any questions on this one? Because next I figured we'd do some absolute value inequality. Okay. Okay. So remember, the way if you have an inequality, let me change the